Okay, in question 5, we've got two things that are essentially improper fractions, top-heavy fractions, where we need to separate them out. Okay, so what you normally do is the grid method for division. Now, this is a very simple case where the grid actually breaks down to something incredibly simple indeed, and you don't actually need that grid, strictly speaking, but you might as well stick to the method you've been taught. So what we're trying to do is we're trying to achieve a grid that when we multiply it out, we'll have an x minus 2 down the side, okay, and we'll have something. There's only going to be a constant here, okay, because the highest power of what I'm trying to get is 2x plus 1, okay, equals x minus 2 times something which will be the quotient plus something else which will be the remainder. Because if I do that, then my 2x plus 1, I can put everything over the x minus 2, and if I do that, this first part, x minus 2 times the quotient divided by x minus 2, is going to give me the a, and then whatever I get here, the remainder part over x minus 2, is going to give me this b over x minus 2. So that's how the method works. So I'm aiming to get 2x plus 1 out of the grid. Okay, well I can get the 2x by putting something here. Okay, I'm going to get a number at the bottom here. Okay, and then I'm going to have to put a remainder, whatever I need to combine with the products of the grid, okay, needs to adjust it to equal the 2x plus 1, so I get my remainder. So here's my quotient, here's my remainder, put them in the appropriate places, and this will simplify to what you want. Okay, you may feel that you can actually go straight to this, okay, and work out what the quotient, what number needs to be in those brackets to get the 2x, and put whatever number you need afterwards to get the minus 1, and you can do that in your head. In this particular case, the grid is, it looks a little bit odd because it is so simple, alright, but you can always use the grid method if you want to. Now, part B of the same question, alright, is, well, once again, it's a top-heavy fraction because we've got 2x squared on the top and we've got a quadratic thing on the bottom which has got x squareds in it. Okay, so once again you can use the grid. Alright, so this time we're going to need to multiply that out. I'm going to be really kind and do that bit for you. So we're going to get x squared minus 2x. We could put plus naught in there. It's always a nice idea in the grid to make sure that we put in even missing terms from our polynomials. Right, and we need the grid to multiply out to give 2x squared plus 8 minus x. So we're basically saying 2x squared plus 8 minus x is going to be, sorry, plus x minus 8 is going to equal, okay, our quadratic factor x squared minus 2x times a quotient plus a remainder, okay. So that once I've got this set up, okay, I can divide by the x brackets x minus 2, and I'm going to get in for the first bit, x brackets x minus 2. This is going to just simplify to a whole number, which is going to be c, alright, or a number, may not be a whole number. And then my remainder, now the remainder, when you divide by a quadratic, has got two terms in it. It's got an x term, so there's going to be some number of x's, and plus some number of a constant, okay? So this bit, okay, you're then going to have to do your partial fractions method on that part. So that's how to do it by division, okay? However, okay, when you have something with a quadratic on the bottom and only it's only just an improper fraction, there's only one constant term here, you might want to actually do this more like you would a partial fractions. Okay, so the other approach to doing this is to multiply up by both of these brackets. So we're going to get 2x squared plus x minus 8 equals c times a factor times another factor plus d times a factor plus e times a factor. Okay, and then we're going to start putting smart values of x in. So you're going to put x equals first thing, x equals second thing. There are two smart values of x, which will enable you to find two of these constants. Okay, once you've used up the two smart values of x, then you can put any other value of x. Okay, so put the simplest number of x that you haven't yet used into this. Okay, and because you know two of the constants already, you can put the values of those in, and the third constant, one you don't know, will drop out straight away. So the partial fractions method works quite nicely for ones that are really top-heavy fractions. Okay, you'll probably find this solution here slightly tidier than doing the algebraic division first. Okay, but you do need to be aware of this algebraic division method because there are questions that force you to use it.